All right, we're still working on special products, and the last one we have to look at in section 6.4 today is the difference of two cubes. They will have the same characteristics that we discussed in the previous video about the sum of two cubes. So two terms, exponents are multiples of 3. All the numeric coefficients are perfect cubes. And the only difference now is that we're working with a situation where we start with a minus in the middle. That's why we call these the difference of two perfect cubes. The factorization is going to be the same as what we did before. So binomial parentheses and a trinomial parentheses. I'm going to again be taking the cube root of 27, the cube root of x cubed, the cube root of 8, and the cube root of y cubed. And I'm going to keep the sign, since I started with the minus, I'm going to keep the sign the same. If you remember, last time we talked about this little pattern, SOAP. So the first sign in the first binomial is the same as what we start with. All right, then to go from this binomial over to the trinomial, we have several little steps to follow. The first one is we're going to square. So the 3x I'm going to square to get 9x squared. Remember that little pattern, 9x squared, where we square. We're going to multiply these two terms together to get negative 6xy, and in here we use the opposite sign. That's what this O stands for. And then to get the last term, we take this negative 2xy and we square it. And close the parentheses, and we're done. So, same sign here, opposite sign there, always positive there as you work through trying to keep track of the signs here. Okay, we'll do one more of these. I think that's all we need. This is the difference of two cubes. Again, I see two terms. I see a minus in the middle. I see an exponent of 3. And I see numbers 1 and 125, both of which are perfect cubes. So binomial, trinomial, the cube root of x cubed is x. The cube root of 125 is 5. And the sign here is going to be the same as what we started with in the original expression. All right, to get to the trinomial, we take the first term and we square it. We take the product of these two terms and we use the reverse or the opposite sign, and then we take the last term and square it. And one more quick thing I wanted to say, after you complete these sums of cubes and difference of cubes, this last expression that you get out here, this trinomial, is always prime, so you don't need to spend any additional time trying to factor that. Let me scroll and see if there was anything else unusual. Oh, here's one that's kind of weird. I've got fractions in it. I wanted to do this one with you. So again, let's go through and check. I see exponents that are multiples of 3. I see two terms. I see an 8, which is a perfect cube. I see a 125, which is a perfect cube. I see a 1, which is a perfect cube. So I'm going to assume this is the difference of two cubes. So binomial and trinomial parentheses. So in my head, I'm doing the cube root of 1/8 I'm doing the cube root of x cubed. I'm doing the cube root of 1 over 125. I didn't say this before, but that splits up into 2 radicals. So you get a 1 on top and a, 5 on the bottom. And then the cube root of y cubed, of course, is y. I didn't quite leave myself enough room. The cube root of z cubed is z. And remember the same sign. So I start off here with a minus, and I keep that same sign there inside the parentheses. All right, going over now to the trinomial. I take the first term and square it. I take the product of the 2 terms and use the opposite sign. It doesn't like me resting my hand on here, I think. That's what's making it do crazy things. And then to get to the last term, we square. So 1/5 times 1/5 is 1 over 25. Y times y is y squared. Z times z is z squared. Goodness, that came out kind of messy. That thing was doing all kinds of strange things. Still doing kind of strange things. Hold on, let me fix that 1 so it looks a little more like a 1. All right, so that's all we need to do in looking at the difference of 2 cubes, and that completes section 6.4 on working with special products.